Hello, this is Seekers Group, students of ITS and ESDV, Humber North Campus, presenting final semester course, Capstone project, which is a job or recommendation engine. Our project sponsors are Aditya Subramaniam, Yasmin Bakhtiari, Nahal Kazimian from company Job O, and our mentor for project is Professor Oren Johnson from Faculty of Humber College. And Seeker Group team members are Alisha, Sandeep, Komalpreet, Trisha, and Raminderjeet, students of Humber College. Topics to be covered in this video presentation are Capstone project overview or scope, content-based recommendation models theory and practical. Now let's get started. Our Capstone project recommendation engine's overview and scope is as following. This project intends to create a recommendation engine that can recommend best jobs to employees based on job scale rating, distance of potential employee from work location, and either way around as well, that is to recommend best employees to a company on the basis of employee skills, ratings, and previous experience using machine learning concepts. The scope includes the aspects of the recommendation engine as follows. Data collection, that is data will be provided by job or company explicitly. Data storage, data filtering, that is to choose the best algorithm after done with evaluation. Machine learning concept, content-based filtering approach using cosine similarity algorithm. Tools and libraries, Jupyter Lab installed on local machine, and Python programming language. Content-based recommendation model theory. A content-based recommender model works with data that the user provides. Based on that data, a user profile is generated, which is then used to make suggestions to the user. For example, as we can see in the diagram below, that the user reads some article, so similar type of those articles are recommended to user in the content-based filtering approach. The math behind the model. So in content-based filtering mechanism, concepts of TF, term frequency, and inverse document frequency IDF are used. TF is simply frequency of a word in the document, whereas IDF is the inverse of the document frequency. These concepts are used to determine the relative importance of a document or item. Below is shown the equation which is used to calculate the TF-IDF score, and point to be noted is that TF-IDF weighting ignores the effect of high frequency words in determining the importance of an item or document. After done with calculating the TF-IDF score, next step is to determine which items are close to each other using vector space model, where each item is stored as a vector and the angle between the vector is used to determine the similarity between the vectors or items, and using the cosine calculation, which is the sum product of vectors. Now let's move to the practical part. So here we can see, first of all, lots of imports are there. First of all, we've made the important required imports for our model from the respective libraries. And after that, we've done the data preparation where loading and processing of data is there. So we have successfully loaded and processed the job O data from their respective database using Robo3D interface for accessing MongoDB database of job O. And after this, for all the, so we can see in here, and after this, for all the required tables for our project, we loaded the data from the respective tables from database to data frames in order to get the respective information. For example, as we can see, we have loaded the data from the skills table from database to data frame in order to get information about the skills of users. So likewise, we've loaded the data from the below tables from the database to the data frames, like we've loaded the job proposal data, and then we've loaded the job skills data, and then we've loaded the user job experience data. So user skills has the information about the skills of user, and job skills has the information about the skills required for job. Post job has information about the jobs posted by companies. User job experience, in this case, out of columns like start date and end date, we've calculated the user job experience in months. And then we can see we've loaded the company user lang data, user skills data, company data. So likewise, we've loaded all the required data for our model. So after we are done with loading all the required data for our model, we've done the merging and joining of tables. So as we can see, df1 equals to pd.merge function has been used to merge or join the data. So we have joined the two data frames, df underscore post job and df underscore job skills, based on common column job underscore id, so that we can get information about jobs posted by employers and skills required for a job in one data frame, which is named as a df1 in our case. And then we have used the head.transpose function to display the data. And then in df2 underscore job is the final data frame for jobs, where df company has been also merged in the previous data frame. And after merging df1 with df underscore company to get all the information about the jobs posted, skills and company in one data frame, df2 underscore jobs has been created, which is used as a final data frame for jobs information in our model. And then filtering on columns is done, and we kept the required columns in our final jobs data frame as displayed. So after we're done with merging final jobs data frames, we done the merging of users data frame. So we've merged df underscore users with df underscore user skills based on user underscore id common column in both the data frames, in order to get the data related to user skills and users in one data frame, which is called as df3 in our case. And then we used the head function to display the first 5 rows of the data frame. And then we further merged the df underscore user lang with df underscore user job experience based on user underscore id. In df, finally created the df4 data frame and displayed the data. And then finally merged the previously created data frames, user data frames, into to create a final users data frame based on user id, and then displayed the data using head function. And after that, we have created a function named as calculate underscore age to calculate a user age from date of birth column. And after done creating the final data frames, we checked for NaN and null values and replaced all the NaN and null values from the data frames. And then after that, we have even merged the final data frames, jobs and users final data frame, into a df underscore final data frame, which is used at the end to display the results. And then after that, we have calculated the distance of user from work location using the Haversine formula. In which firstly we change the latitude and longitude of user and company data into a numeric values, and then applied the formula, and in this way we calculated the distance in kilometers in between user and work location. and then we created the final, and then we splitted the users in jobs data into testing and training in 20:80 ratios and proportions, and then created the input string which will be fed to the model in order to generate recommendations. So in order to create a input string to be fed to the model, we use the user title, description, job proposal, description columns, and create from df underscore users data frame and created df underscore users description data frame, which will be an input to the model. And then in order to judge the machine's performance qualitatively, we use the TF-IDF factorizer function from scikit-learn library, which transforms text to feature vectors that can be used as input to estimator. And we removed the stop words and computed the TF-IDF metrics required for calculating cosine similarity and displayed the shape of metrics as well. And then we computed the cosine similarity metrics using linear underscore kernel from sklearn library. After that, we created the index for the user ID column, which is used further in function to get the most similar users. And after that, we created the get recommendations user by function, which accepts the user ID, and based on cosine similarity, it generates the matching jobs for this user ID. And then we can see to this function we passed the user ID and we got the job IDs in return, which are matching results for this respective user ID. But to make it more clear, because these IDs are like not very clear in understanding, so again we created a function called get job ID. So these created job IDs. So we created a get job ID function which accepts user ID list. So the user ID list and displays the matching results for this user ID. So for example, in this we can see we have called the get recommendations user by function and pass the user ID. So we are saying that generate job recommendations for this user ID, which are job IDs as output. After this, we have also created a function which is called get job ID, which is accepting user IDs as list, which will recommend jobs to users based on skill ID and filtering the output with distance, saying give the results for this user ID and also make sure that the distance is less than 100 kilometers, and getting the output as below. As we can see, for this respective user ID, we have got the result as company name 1 LLC and distance is 0, which is like less than 100 kilometers, and job description. So in the similar way, we have used the get recommendations function, which is used to generate recommendation of employees to employers. Likewise, in the same way we done for this generating jobs for users. And at the end, if we can see get user ID, we will pass the job ID and we'll get the respective user IDs. Thank you.